Okay, so basically, like I said, we are going to talk or to focus on redox reactions. So under redox reactions, you need to know what a reduction reaction is, because for us to say this is a redox reaction, meaning that there is a combination of oxidation reaction and reduction reaction. So from the same two topics, what are you supposed to understand the most? One, you need to know how to come up with the so-called oxidation numbers, how to come up with the so-called oxidation numbers. Apart from that, we also have to understand more on how to balance the reactions in acidic and basic media. To balance the reactions in acidic and basic media. So, if you know that, you have also to focus on the rules that we posted in the other video. We know how to find the so-called oxidation numbers and how to describe to say this is oxidation reaction, as well as to say this is a reduction reaction. So minus wasting our time, today we are going to focus on this topic, so-called uh, oxidation oxidation and reduction reactions. The further to these same topics is what we call uh, redox reaction. The further to those topics is what we call redox reaction. Okay. All right. So here, what exactly are you supposed to know? First of all, you need to know how to define the oxidation reaction, reduction reaction, and also redox reaction. You have to understand how to define those to my simple terms. In the previous video, we tried to look at what exactly it takes for you to understand to say this object, I mean, this element is having these oxidation numbers. We had some rules. We know we had some rules, a lot of rules were there. The first rule that we were given, or I would just like to put it like this. I'll list down all the rules that we normally use for us to understand to say this substance or maybe this element is having this as the oxidation number. Okay, so the first rule we are saying all the elements in their natural, or the elements in their natural state, they have an oxidation number of 0. What does it mean? We know that there are so many elements that exist as the atomic elements. A good example can have hydrogen. We can also have nitrogen. If this is just existing as an element alone, automatically it will have an oxidation number of 0. But if it is in a form of a compound, it will have a certain number as its oxidation number. So nitrogen, we can also have even fluorine. Or this, if it happens, even oxygen itself, if it exists as a diatomic, or maybe it is in its natural state without combining it with any compound, or if it doesn't make any compound with any other element, automatically you say that is that element is having an oxidation number of 0. Okay, so that is the first rule we have to understand. The total oxidation number for for a compound having a charge is equal to the same charge. Okay, what does it mean? We can have something like this. We can have, suppose we have, how can I put it? Suppose we have, okay, I'll write it like this. Like this. This is what we call nitric acid. I have to put a 2 somewhere there. This is what we call a nitric acid. So meaning that the sum of all these elements that are found in this compound, their oxidation numbers, if you add the oxidation number for this one, that one, that one, you have to equate them to what? To a charge. And how do you write this? You're going to understand that there is another rule which applies to say, in a compound, the oxidation number of hydrogen and oxygen, they are given already. Meaning that, like for this one, you find that its oxidation number is going to be plus 1. The oxidation number for oxygen has to be negative 2. So if you have negative 2 as the oxidation number for this element, you look at how many elements you are having. If we have 3 different elements for this one, or for this compound, that is on part of oxygen, meaning that for you to find the total sum of oxidation number for this entire thing, like for nitrogen, because nitrogen here, it is in a form of a compound, meaning that it has now been removed from this state. Why? Because this rule is saying every element which is in its natural state, its oxidation number has to be equal to 0. So in a compound, meaning that nitrogen won't have an oxidation number of 0. Why? Because it is not in its natural state. It is combined with some of the elements. What are you supposed to do? Meaning that here you're going to focus on this one. You find the oxidation number for this one. Again, in a compound, what you're going to understand the most is, in a compound, the oxidation number of oxygen has to be equal to negative 2, comma, hydrogen has to be equal to positive 1. When writing for oxidation numbers, we always put a sign in front of a number. If the oxidation number for this one is 2, you have to put plus, because that's the meaning of just writing 2. You don't write a 2 alone. That doesn't give you a sense if you write a number alone. Now, if you follow this one, we're saying in a compound, that's where you're going to find that the oxidation number of oxygen has to be what? Negative 2. Same applies to this one. You're going to find that its oxidation number must be equal to positive 1. But in this statement, everything is in its natural state, meaning that here you must get the oxidation number for this one as 0 if it is standing as element alone. Same applies even this one. So here, since in a compound, here we're saying this is going to have what? 0. And then in a compound, this statement is trying to oppose, to say in a compound, the oxidation number for hydrogen has to be positive 1. For hydrogen has to be positive 1. For oxygen, you must have that is negative 2. Meaning that here we're going to focus on this part to find its oxidation numbers. And since this entire compound is raised to a charge of negative, meaning that the total sum of all the oxidation numbers here must be equated to what? To the charge. And how are you going to find the oxidation number for this one here? You say X for nitrogen, then you are going to add the oxidation number for hydrogen. Since we have 2 hydrogen atoms here, you are going to say 1 multiplied by 2. Say plus 2 multiplied by positive 1. Say plus, how many do we have for oxygen? We are having 3 oxygen atoms multiplied by negative 2. Then you equate everything to the number which is here. This is just one and the same like negative 1. If we had negative 3 here, or we write 3 negative, what are you supposed to do? You have to equate everything to negative 3. So if you add, you're going to get the oxidation number for this one, which is for oxygen. Those are just simple rules that we have to remind ourselves. All right, so The other rule which you have to understand the most is all the alkali elements have an oxidation of +1. In short, all the group 1 elements, they must have an oxidation number of 1. That is if it is part of a compound. So here I'll write in a compound. These are my simple rules. Don't make a mistake of changing the meanings. You're going to be getting wrong answers. Here we are saying all the group 1 elements in a compound, they have an oxidation number of 1, meaning that suppose we have nitrogen, sodium alone without combining it with another element to form a compound, automatically this is going to be what? 0. It will have an oxidation number of 0, meaning that you are following the first rule. Why? Because the first rule says everything or every element in its natural state, it must have an oxidation number of 0. So if it here you write sodium alone, automatically you're going to get 0. But if you combine, you say sodium hydroxide like this, you'll find that here this is going to have an oxidation number of 1. This one is going to have an oxidation number of what? -2. That one is going to have an oxidation number of um, +1. To find the oxidation number for this entire compound, you add like what I'm from saying, meaning that automatically the oxidation number for this entire compound is going to be equal to 0. Why? Because this one, it is in group 1, it will have +1. This one, it must have +1. This one is going to have -2. If we try to add, we're going to get 0. Simple as that. Okay, we go to the other rule. We say all the group 2 elements in a compound, comma, have an oxidation number of +2. That is the second, that is the other rule that you have to know the most. So as for today, we have to focus on this as our important thing. We say redox reaction. Redox reaction. What exactly is the same redox reaction? So this redox reaction is categorized or divided into two different types of the reactions. The first reaction, which has to be on this part, you cut it from here. You cut it from somewhere there. What does it mean? This actually means that from here, this one which is written as red, it comes from a word reduction. What about this one which is written ox? This actually, it is oxidation. Okay, so since I've tried to divide these reactions into their respective categories, what you're going to understand the most here is if you want to define the so-called reduction, reduction is divided into two, is defined into two types, or into two different categories, or rather into two ways. The first way, you say this is the removal of oxygen from a reaction, that is a reduction, meaning that this one is going to be the addition of oxygen to the reaction. Apart from that, you say this one, it has to be the removal of electrons from the reaction. This one is going to be the addition of electrons to the reaction. Reduction, for you to say this object, this element has been reduced, meaning that it is being oxidized. How can you say? Say this thing has been oxidized? It's because suppose you have a given charge. If you have a given charge, like for +2, you're going to understand that for you to remove that +2, you have to add some electrons, meaning that that same object, that same element, if it gains electrons, automatically it is going to get reduced. Why? It will change from positive going to the negative. Reason being, the positive which is on top and the number of electrons you are going to add, they will cancel each other. Okay, so the definition in short for redox reaction, this is the reaction which involves oxidation and reduction reactions taking place simultaneously or taking place at the same time. That is the simple definition you can give. Redox reaction, we are saying it is a type of reaction which involves oxidation and reduction reaction at the same time. Under redox reaction, the most things that you have to understand the most is one, how to find the so-called oxidation numbers. Two, how to balance in acidic and basic media. And that's what we're going to focus on today. What are some of the steps that you're likely to take when balancing in acidic media and also in basic media? So here we are going to focus on two different things now: balancing of reactions in acidic and basic media. Unless if you've forgotten how to define what an acid is, but if you still remember, you won't be having challenges even if I'm to demonstrate what I'm going to show you now. Yeah, so the best way of defining what an acid is, I would define it based on your secondary understanding. An acid, if you say an acid, this is just a substance which produces, which when dissolved in water produces hydrogen as the only positive charged ions. That is what we call an acid. Meaning that even when you are trying to balance in acidic media, you are going to observe that at the end of the reaction, you only have hydrogen ion present in that same reaction with other neutral compounds. If you go to basic media, you want to balance in basic media, meaning that that same basic media, or maybe a reaction you've balanced in basic media, it shouldn't be having hydrogen ions again. It must only have hydroxide as the only negatively charged ions. And how do you define the same base? Base is just a substance which, when dissolved in water, produces hydroxide as the only negative charged ions. Suppose you have this as your example. If we have copper, iron plus, we can also have we can also have copper. This one is having a charge of 2, producing iron having a charge of 2 plus copper, like this. So the way we handle these two questions, these are simple questions that you shouldn't be giving us challenges when it comes to balancing. The way we do balance these, if they say balance in acidic media, balance in basic media, balance in blah 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 blah, what you should always um, what you should always understand is, for you to understand to say this is a reaction, this reaction is an acidic media, this reaction is oxidation and this one is reduction reaction. You can only do that if you separate these reactions into two reactions, and those two reactions, we call them as half reactions. That's why in the previous video, the way I defined what oxidation number is, what oxidation reaction is, I defined it based on the same half reaction. To say this is a half reaction which involves the increase in the number of oxidations of a particular element. Same applies to reduction. You say this is just a half reaction which involves the reduction in the number of oxidation numbers. So here you can't take this reaction and then you equate it to that to make a half reaction. No, you have to make sure that you relate this to what is happening there. But before that, you have to understand to say which one or what are the differences in terms of oxidation numbers. In short, once you separate these reactions into two, for you to clearly understand to say this is a reduction reaction and this is oxidation reaction, first of all, you have to follow the following rules. So the first rule which you have to understand the most is in short steps to say. So let me just try to demonstrate. I would like to start with this one, what exactly it means for you to balance in acidic and basic media. The same thing which I'm from showing you. Say this is iron plus copper 2 plus, giving us iron 2 plus plus copper. So if we want to separate these two, this reaction into two different half reactions, you have to make sure that once you separate them, you label them to say this is a reduction reaction, this is an oxidation reaction, meaning that you're going to have the reaction from here up to that. This is going to be a half reaction on its own, and also from here going up to that one, this also is going to be a half reaction. Now, how do you identify to say this is an oxidation reaction and this is a reduction reaction? You only identify based on the definitions of oxidation and reduction. Remember, we're saying oxidation means an increase in the oxidation number. Reduction means decrease in the oxidation number. So, if you want to check to say this is oxidation reaction, you remember we're saying every element or maybe every compound existing in a form of an ion, then the same charge it is having will be the oxidation number for that particular ion. We have two different things now here. The reaction which is involving this one having an ion now. So for something to acquire a positive charge, what does it mean? For something to acquire a positive charge, what exactly does it mean? This actually means that it has lost some electrons. So the losing of electrons, we call it an oxidation. Increase in oxidation number, it is also called oxidation. Get these points cleared. If something has lost some electrons, it is positively charged now, meaning that it is experiencing what we call oxidation reaction. Why? Because the number of protons in that same thing will now be less than the number of electrons. That's why it is going to carry a positive charge. Then for reduction, meaning that for something to get reduced, it has to lose some electrons. If it loses some electrons, if it gains some electrons, not losing, sorry. If it gains some electrons, automatically we're going to say that that same thing has experienced what we call a reduction reaction. But you find that for it to come up with a negative charge, since it is gaining the electrons, definitely you're going to say that object has been what? Has been oxidized. The meaning of being oxidized, meaning that it has lost the oxygen, its oxidation number has been reduced. So here, if you want to check clearly to say this type of reaction is oxidation and this one is reduction, you look at the charges, because everything here, like this one, we are saying this is in its natural state. What will be the oxidation number for this one? You have to say this is going to have oxidation number of 0. So since this one is carrying an ion on this top part, you find that we only have this same thing. So since it is having a charge of positive 2 here, meaning that its oxidation number is going to be positive 2. That is according to the rules that I'm from giving you. Same applies to this one. Initially, it is having a charge of 2. The same charge here is going to be its oxidation number, which is going to be plus 2. Then since it has now been reduced from 2, it goes to 0. The reducing, or maybe the reduction in oxidation number, will call it what? What name is given to the reduction in oxidation number? The reduction in oxidation number, will call it but people are not following. Okay, so if there is an increase, yes, you can talk, Mr. Wilson.
What did you ask? Sorry,
I'm saying like what name is given to the type of a reaction whereby there is a reduction in oxidation number. What name is given to that reaction?
A reduction in
Okay.
oxidation,
Hmm.
isn't it? Oxidation.
Okay, so if we are increasing in oxidation number, we say that reaction is experiencing what we call oxidation reaction, meaning that for this one, it is being increased from 0 to positive 2. For this one, it is being reduced from 2 to what? To that one. So to write the same half reactions for these two reactions, what you're going to understand is you're going to write them like this. Say equal to 2 plus. This is what we call oxidation reaction. You come to this one, the one which is reducing from positive 2 going to 1. What name is going to be given to the same type of reaction? If we have Cu 2 plus giving us Cu, this is a reduction reaction. So even if you had a compound for this one, still you need to find the oxidation number for this one from the same compound. I'll show you another example so that you can clearly understand what I'm trying to talk about. So we have two different reactions, and this is a half reaction, and also that one is my half reaction. Okay, now what are you supposed to do here? What will be the second thing? The first point, I remember we said you have to split the reaction into two half reactions. We've splitted this gamma reaction into these two. What next now? Okay, so yeah, suppose we have that point only applies to a situation whereby you are having any compound here which is having oxygen. If you have any compound here and you've separated these reactions into their half reactions, you are going to understand that you can only use that same point if you have oxygen uh, also be part of the same reactions. So in this case, since we don't have oxygen in either of these two, what are we going to do? We are going to jump that same point. Then we're going to go to the point which says you balance um, the elements other than oxygen and hydrogen. How do you balance? What you're going to understand here is this is already balanced. We have one of this, and also that side we also have one of that. Same applies even here. We have one of this and also one of that. Then now you have to go to the other point which says you have to balance the oxygen, you balance the hydrogens, all those simple stuffs you ignore them because we don't have oxygen and hydrogen in these reactions. You go to the point which says balance the charges now with electrons. So since we have these numbers as the oxidation numbers, this one initially it is having 0, here it is having positive 2. For you to find the difference between the oxidation numbers here, what you should do, you always put the difference in what? In modulus. We learned about this, and I said yesterday to say if you are having a number which is negative under modulus, it will come out as a positive number. What I mean is this. For this one, this is the final number of oxidation, which is going to be 2. We say minus. The initial number of oxidation is that one, 0. We are going to get what? 2. Meaning that for this reaction, it lost 2 different electrons. So for me to make sure that this reaction is now balanced, what are you supposed to do? You add the same number of electrons of um, to the part where there is a bigger number of charge. Here we are having 0, but here we are having 2. For me to balance up this, meaning that I'm going to add 2 electrons on this given part. Why am I adding to this part? Because I want to make sure that this right hand side is also neutral. Then this thing is going to be said to be balanced. So you come here, since we're saying you have to add this number of electrons, the reason why we're trying to subtract is because I want to know how many electrons were lost. So you're going to write it like this now. Fe, this is going to be equal to Fe 2 plus, you say plus 2 electrons that are going to be added to the right hand side. Meaning that these 2 protons which are there minus 2 electrons, we are going to get a neutral thing. It is going to be balanced now 0, 0. So this becomes the equation for oxidation. You do likewise to this one. You need to find the difference between the what? The oxidation number. For this one is 2, that one is 0. So you're going to say 0 minus 2. You put everything inside the what? The under modulus, I mean. You're going to get plus 2. Meaning that this number of electrons is the same one that this reaction had what? Gained. To mean it gained electrons, meaning that this number of protons and the number of electrons it gained, they're going to cancel each other. It's more like you're saying positive 2 minus 2. You're going to get 0 for that same type of a calculation. So, meaning that for reduction reaction, you have to add the number of electrons to the part that is having more charges. So for this one, we have 2 charges, but that one is not having any charge. We are going to do it like this. Sorry. Cu 2 plus, you said plus 2 electrons added, we equate everything to what? Cu. This also becomes a reaction. So if you check now, everything is balanced. This is when now you have to combine the two half reactions. How would you combine? You say this plus these ones that are on part of the reactant. Then those things that are going to be common on part of the reactant and part of the product, you cancel them out. So you're going to have Fe plus Cu 2 plus, you say plus 2 electrons, you say equal to, we are going to have Fe 2 plus 2 electrons plus that is Cu. So if you check clearly, what you're going to understand, we have 2 electrons here and also 2 electrons on that given part. The other type of reaction that we're going to solve now, you see what I mean when I say you have to cancel this out and how you can balance the number of electrons and how are you supposed to balance the what? The substances that are not even in a form, or maybe that are not having oxygen. So you cancel this, you cancel that, meaning that your reaction is going to be Fe plus Cu 2 plus, giving you what? Fe 2 plus plus something like this. We've returned back to where? To the original thing. What does it mean? This actually means that we're going to have 2 charges on the part of the left hand side and also 2 charges on the part of the right hand side, because this one is not having charge, to have 0. Even this one is going to have a 0 charge. So this plus 2, we are going to get 2. This plus, 2 plus 0, we are going to get 2, meaning that this thing is balanced in acidic media. Let's try to focus on a question now which requires us to use the so-called oxygen, how to balance using blah, 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 something like that. Okay. Okay, let's try to look at this question now. If they ask a question like this, they say balance the reaction in acidic media. So if you have been given a reaction like this one, okay, Cr2O7 2 negative plus Fe 2 plus, giving us Cr3 plus and also Fe3 plus. So if you check, you're going to have a reaction from here going that side and also a reaction from here going that side. You write them like this. And also let's be attentive. Try to focus on what I'm trying to guide you. Let's be attentive. Okay, so this is the other thing that we have to understand the most, and we have to pay much attention on this come part, because that's where a good number of people are facing some challenges. Now, if you want to separate this reaction, the first step we are saying you split into what? You split the same reaction into half reactions. First of all, you split into half reactions. So we are going to have, okay, we are going to have something like this now. Cr2O7 2 minus, giving us Okay, we're going to have 3, sorry, 3 plus. That is the first half reaction. We're also going to have 2 plus, giving us Fe 3 plus. If you check here, for you to know what is the oxidation number for this one, we are saying you consider the charge. Here you can't know the oxidation number for chromium. Why? Because it is part of a compound. It is not in its natural state. It is part of the compound in reaction with what? With that one. Okay, so, but this one, it is something which is straightforward. This one has a charge, and also that one is also having a charge. To know the difference in terms of the charges, or rather electrons that were gained and the like, what are you supposed to do? Meaning that you have to know, or you have to find the difference in what? In the oxidation number. For this one is going to have an oxidation number of 2 following the charge. For this one is going to have oxidation number of 3. If you find the difference between these two, you say 3 minus 1, 2, I mean minus 2, to find how many electrons were lost for you to come up with this charge. Automatically, what you're going to know, it is going to give you an electron, which is only 1 electron. So you're going to add this number of electrons to where? To the side that is having more charges, something like that. That becomes the first half reaction. You have to come to this one now. But before you even understand what is happening here, you need to know the oxidation number for that one. We are saying you follow the oxidation number of something which is having a charge as the same what? I mean, if it is having a charge, that same charge is going to be the oxidation number of that given element or a compound. So for this one, you are going to understand that it will have an oxidation number what? As 3, because we are following the charge. But here, you want to find the oxidation number for this one. We have 2 chromium here. We have 7 oxygen atoms, but the entire compound is raised to a charge of -2, meaning that the summation of oxidation numbers here, they must be equal to -2. So here, I want to find the oxidation number for this one. Why? Because it is the one which is going to be produced on that given part. So you just say 2 multiplied by x for this one. Since we're having 2 of them, you say plus 7. We say the oxidation number of oxygen in a compound has to be -2, meaning that the whole lot of this material we are going to equate it to what? -2, which is that given charge. So we are going to have 2x minus 14 equal to -2. If you take this to the other side, we are going to have 2x equal to -2 plus 14. All right, so you divide by 2 by 2. X is going to be equal to, that is 12 over 2. We are going to get the oxidation number for chromium in a compound is going to be +6. Now, if you write this reaction now down here, write like this: Cr2O7 2 minus producing Cr3 plus. This one we're saying it has an oxidation number of +3. This one is going to have an oxidation number of +6, meaning that the difference between the two oxidation numbers must be put inside the what? The modulus. We are going to say 3 minus 6. Here we are going to get 3, meaning that 3 electrons are the ones that were gained. And where are you supposed to put the same number of electrons? You put the same number of electrons to the side that is having more oxidation numbers. So in this case, meaning that if you want to write this one as your half reaction again, you are going to put 3 electrons on the part of the left hand side, because that's where you are having 6 as the oxidation number for that given reaction. So you're going to have Cr2 O7 2 negative plus 3 electrons that were gained. You say equal to, or any number which is going to be under modulus, which is having a negative inside the modulus. If you remove the modulus, you're going to get a positive number. We don't have a negative number under modulus. Even if we have -3, so long it is under modulus, to write it in a correct way, this is going to be 3. Okay, so this becomes the half reaction, right? This becomes the half reaction. The reason why we're putting under modulus is because we know that here we can have a less numbers compared to what is going to be on your left-hand side. And if you subtract the final minus initial, you're going to understand that you can get a negative number. That's why you put it under modulus. So any number under modulus, uh, it has to be, okay, I'll do that. It has to be what? It has to be positive, something like that. So we have two different half reactions now, two different half reactions. We have this one as our half reaction and also this one. So what is the next thing that you have to do in this case? We are saying you balance the things that are not what, in short, you balance the elements other than hydrogen and oxygen, meaning that you're going to focus on the part that is having um, more I mean, like for this one, you see that here we're having two of these, but on your right hand side you only have one, meaning that you have to balance this one which is not having what, the oxygen. You are going to balance this one. The next thing now, you have to go into balancing oxygen with the water. You balance oxygen with water. How would you balance? I'll show you in the next what, in the next page that I'm going to flip on this one. All right. So we have two different half reactions here. The first one, we are saying the first half reaction, if you check, so we are having F A 2 plus, which is equal to, we are saying F E 3 plus, we have an electron at this given point. This reaction is for what? This is oxidation reaction because there is an increase of oxidation number from 2 to 3. So this becomes oxidation reaction. Okay, we go to the other half reaction. Cr2 O7 2 minus. We are saying we have 3 electrons that were gained. You equate everything to Cr3 plus. So if you check here, the meaning of balancing oxygen or hydrogen elements in this reaction, you balance first of all the same reaction, the same elements. So you're going to understand that we have two chromium ions, two chromium atoms here, but here we only have one. To balance this, you have to add two in front of, before this one. Now, after that, you look at these two different reactions. You have to balance these two now with oxygen. If you don't have any oxygen here, you leave this reaction alone. You don't balance it. You leave the reaction alone. You come to this given part. What are you supposed to do to this same reaction? You have to make sure that you balance this using oxygen. You balance the oxygen using water molecules. So if you see, we have 7 oxygen atoms on this given part, meaning that on the right hand side, you're going to add 7 water molecules to balance the sum of what? The sum of oxygen. So here I'll do like this. I'll say plus 7 H2O, meaning that now we're going to have 7 water molecules and also 7 water molecules. But since I've introduced water here, there is something which is disturbing me. I've also introduced what we call hydrogen, meaning that the other concept or the other point we raised, we say you have now to balance the hydrogen ion with hydrogen. You have to balance hydrogen with hydrogen ions, meaning that you're going to balance this one. Since we have 7 multiplied by 2, we are going to have 14 hydrogen ions on my left hand side. You have to put 14 hydrogen ions. And how are you going to write this? You're going to write it like this: plus 3 electrons plus, you're going to add 14 hydrogen ions. Why do we add hydrogen ions? Because we're balancing in acidic media. Remember the definition for an acid, a substance which when dissolved in water, you're going to come out with the hydrogen as the only positively charged ions. This one, that's what it means. You say equal to, you have 2 chromium ions plus 7 water molecules. Now, if you check, here we have 3 electrons, but there we have what? 1 electron. What is the other point trying to tell us? The other point is saying you now balance the charges with electrons. So I'll balance the charges from this one with the electrons. How many electrons are you supposed to have in this given reaction? You have to make sure that you balance with these, meaning that I'll multiply this entire function, this entire expression or rather equation by 3 to get the same number of charges as that one. So we are going to have 3. If you multiply this thing by 3, we are going to have 3, 2 plus, you say equal to, you multiply again this one by 3. In short, we multiply throughout by 3 to balance up this one with that. If suppose, for instance, if we had 5 here, I would have multiplied this reaction by 5. Then we are going to have 3 F E 3 plus 3 E like this. This is when now you are going to have that concept of saying, first of all, before you combine, you can just cancel the electrons. Then you combine what? The two reactions, meaning that you've balanced an acidic media. So you are going to cancel this and that. Why am I cancelling? Because these electrons which are found on this part, they are found on the part of the reactants, and this one is found after the equal sign in this given equation. So if I was to add this plus what is here, you are going to find that these electrons are going to be on your right hand side and these are going to be on your left hand side. So now you combine, now you say combine the two half reactions like this. So we are going to combine this reaction which is here and the reaction which is found at this given point. How are we going to combine them? We are going to have Cr2O7 2 negative plus 3F. I'm taking this and that, then I'll come to that one. 2 plus 14 hydrogen ions, giving us 2 plus 3, then you add the water molecules, 7 water molecules. Okay, so we've tried to split these reactions into half reactions. Remember, we're trying to balance in basic media. The process is just one and the same like what we are from doing in acidic media. The only difference is that at the end of acidic media, to shift from acidic to basic, you have to add the number of hydroxide ions based on what have been given as the number of hydrogen ions on both sides of the reaction that we combined at the last point of balancing in acidic media. So if you check here, do we have anything that we can balance with in terms of, as in which element do you think we can balance here? If you check on top here, we're having 2 of these, but here we only have 1, meaning that this one has to be balanced like this one. We're going to have 2 of silver metal. Now, if you check clearly, you're going to understand that we have 1 oxygen at this given point, meaning that for me to balance this oxygen, I must introduce the number of water molecules to this given part. How many water molecules are going to introduce? Since we have only 1 oxygen here, you have to introduce 1 water molecule for this one, meaning that oxygen is going to balance. But since now we are going to introduce water molecule, we are going to come up with another thing which is going to disturb us. In this case, we're trying to talk about hydrogen, meaning that I would do like this. Giving us. So since we've added water molecule, oxygen is balanced and that one. So since we've introduced water molecule, we also have this one which is a disturbance, meaning that on my right hand side, I must add 2 hydrogen ions to balance up with that one, meaning that everything now is going to be well balanced. Meaning that everything now is going to be well balanced. If you check clearly, you are going to understand that here we don't have water molecule. I mean, in this one, we don't have water molecule. Meaning that the thing is, you just have to balance the number of electrons. You balance the charges with the electrons in this given part. What are you supposed to do to this reaction for you to come up with the same number of electrons as this one? You have to make sure that you balance this one using a coefficient which is going to suit with that, of which I have to multiply throughout by 2. Then we're going to come up with 2, okay, open, going to have Ag as water molecule producing Ag2 plus E negative plus 2 hydrogen ions. If you try to multiply throughout, you're going to have 2 Ag plus 2 water molecules plus 2 sorry, Ag to, sorry, because here initially we had this one already dying, so we're going to have four of these. Sorry for that mistake. So I have to add two. Then here we're going to have two electrons on this part and also four hydrogen ions. Now you combine these two, you combine this with that one. But before you combine, what you're supposed to do, you cancel this and that one. Why? Because even if you combine them, that's when you can add. Still, they're going to be cancelled because they're the same. Now you start with this one. I'll say two. In combination, you start with that one. Even this one, you can start with whichever. So we're going to have Z. Okay, I'll say, yeah, Z 2 plus. I'm going to say plus. So since here we only have this one as part of the reactant, we'll come to this one. Plus 4 Ag plus 2 H2O, giving us, you come here, we're going to have Z N as zinc plus A, sorry, plus 2A G2 plus 4H, like this, yeah. So if you check clearly, you're going to understand that this is how we balance in acidic media, right? Now, if you want to shift from acidic media, you want to go to basic media, I said you have to add hydroxide ions. You can ask, you can ask, you can ask.
Haven't you left out oxygen on your right side of the equation?
Which oxygen? Of this one?
On
He,
yes, sir.
okay, thank you for that correction. All right, so what you're going to understand is this. So here we forgot oxygen, I've added it there. Okay, so you add hydroxide ions based on the number of hydrogen ions you are having at this given point, meaning that I'll add 4 hydroxide ions on each part. So I'll start from here. I'll add, I'll say 2, sorry, Zn 2 plus 4Ag plus 2H 2O plus, we have to add 4 hydroxide ions, negative, giving us zinc plus 2A GO, put a 2 there. So if you add 4 hydrogen ions plus 4 hydroxide ions, the combination of these two, you are going to get 4 water molecules. We are going to get 4 water molecules. Okay. So since we have this reaction, which is zinc 2 plus, and we also have plus 4 Ag plus 2 water molecules plus 4 hydroxide ions, giving us zinc plus 2 Ag 2O. Now, if you combine 4 hydroxide ions plus 4 hydrogen ions, we are going to get 4 water molecules. So what you're going to understand here, we have 2 water molecules on this given part, and that side we have 4 water molecules. So meaning that I can cancel this number of water molecules and also reduce 2 water molecules at this given point. We're going to have 2 water molecules remaining on my right hand side, meaning that now you've balanced it in acidic media. Now you've balanced it in acidic media, because we're saying we're going to have 2, sorry, going to have Z N 2 plus 4A G plus 4 hydroxide ions, giving us zinc plus 2 Ag, and say plus 2 water molecules. This now is balanced in basic media. Why? Because if you check, we only have this one as the only negatively charged ion. So if you get back to how to balance in acidic media, what you're going to understand is there is a difference between this one. For acidic media, we came up with hydrogen ion as the only negative, I mean positively charged ion in that same reaction. Then for this one, we are coming up with this one. This automatically shows that we've balanced this in acidic, I mean in basic media. We've shifted from acidic, now we are going to basic media. That's how we balance, or that's how we differentiate between how to balance in acidic media and how to balance in basic media.